Hello viewers, good afternoon. Myself Professor T. N. Oza, presenting to you new video. In this video, I have taken up six very simple and interesting questions on spectroscopy along with their appropriate answers. The purpose of this video is to make you aware how to answer the questions precisely and succinctly. One more thing you can add to my answers, I have not included that. You can draw hypothetical spectral lines also to make the diagram answers more clear. Due to lack of space, I have not included that. But the theory part is complete. Let us begin. Question 1. Why is the infrared region so named? Give its energy distribution and spectroscopic uses. The answer to this question reads like this. The infrared region of electromagnetic radiation occurs just below the red part of the visible region. In Greek, infra means below, hence the name. Now I have included the various measuring parameters. How do they change? Energy, frequency, wave number, wavelength. So far, UV, visible, IR and microwave and radio waves, they change in the direction shown. Here radio wave, the heading has got shifted. So it is after microwave, not below UV visible. The IR region is conveniently divided into three parts. Near IR, which extends from just below the visible part to about 800 nanometer, which is about 800 nanometer, and extend up to 4,000 reciprocal centimeters wave number. It is often examined for the investigation of overtone vibrational absorption bands of compounds which occur at twice or thrice the value of the frequencies of fundamental vibrations. These appear as very weak bands, if at all. Mid-IR region extends from 4,000 to 667 centimeter inverse. It is the most useful region as it contains the fundamental vibrational absorption bands of various groups like OH, CH, C double bond O, NH, etc. Then comes the far infrared region, which is from 1000 to 50 reciprocal centimeter, low energy region. And it is used for the examination of either carbon halogen bonds or metal ligand bonds. Because these bonds are weaker bonds, their vibrational frequencies are low, so they are often studied in the far IR region. The vibrational frequency formula is given here in wave number 1 upon 2 pi c root k by mu. K is the stretching force constant, mu is the reduced mass. Higher the reduced mass, lower the frequency, higher the k value, the frequency. Interconversions are given. Reciprocal of wavelength gives wave number. Wave number multiplied by C gives frequency. Energy in per joule per mole is calculated by Na cross H cross C over lambda. Care should be taken for using the correct units. Question 2. How can you distinguish between 3-hydroxypropanoic acid and methyl ethanoate from their spectra? The answer is carboxylic acids and alcohols show OH stretching absorption very broad between 3450 to 3200 reciprocal centimeter. Due to hydrogen bonding, these bands are very broad. And their carbonyl stretching absorption appears at about 1700 reciprocal centimeter. In case of esters, firstly, you don't find OH band. Secondly, their carbonyl absorption stretching peak appears at about 1745 reciprocal centimeter. In this way, you can easily distinguish between the two. Third question, suppose you are given a forensic problem, a sealed blood sample from the police department, and you are asked to identify the unknown murderer. They have picked up three suspected persons. You have to find who is the real, who is the culprit, who is the murderer. So IR spectroscopy is used. The blood sample of the three suspected persons has to be matched against the sealed blood sample. The correct match will solve the problem. Question 4. In which case cyanide stretching frequency will be the highest? Terminally bonded MCN, M is metal, bridged MCN, metal on both sides, and HCN. You see in HCN, H is very light atom, reduced mass, therefore frequency of CN will be the highest for HCN. Then it will be higher for the terminally bonded CN because there is triple bond. In case of bridged, there is double bond only between carbon and nitrogen. So in that case, the frequency will be lower. Question 5. Which spectroscopic method can be used for the following studies? First is oxidation of isopropyl alcohol to acetone. Second is comparison of commercial sample of flavoring agent vanillin with an authentic sample. Third is detection of impurity in a commercial sample of clarified butter, ghee. And last is detection of functional groups in organic compounds. Their answer is like this. Rate of oxidation of isopropyl alcohol is given by dx by dt equal to Kn Px power n. Here Kn is the rate constant, n is the order of the reaction, and Px is the concentration of the product against time t. This can be monitored by measuring the area of CO absorption peak, which appears at about 1720 reciprocal centimeter as a function of time. For the second problem, superimposable IR and co-TLC can also be used. Mixed melting point method is also helpful. Third answer is same as 2. Fourth problem, the IR spectrometry is useful for this purpose. The characteristic IR absorption frequencies of various groups, particularly in the range 4000 to 1600 centimeter inverse, are very, very important, very informative, very indicative. This region is called the functional group region. It is helpful in the identification of the functional groups in the molecule. The region below this, that is 1600 to lower region, 400 reciprocal centimeter, is called fingerprint region. This contains too many sharp peaks. All peaks cannot be assigned. But for confirming the identity of two samples, this region is very useful. Therefore, it is called fingerprint region. So in this way, IR spectroscopy can be properly understood. I will continue to giving more videos, taking up simple questions, their proper answers. Please read them carefully. I hope this will be very helpful for you. Thank you very much.